Last video you guys learnt about Newton's second law of motion. So in this video you'll see certain observations and certain examples of Newton's second law. Okay? See, first observation what we can do is, suppose let's say you have an object, okay, an object of mass m, and no force is acting on the object. So F is 0. If F is 0, then your acceleration has to be 0. Because the mass of an object is never 0, right? So, if F is equal to 0, then A is equal to 0. Now, what was Newton's first law? An object at rest or uniform motion. So, this will always stay at rest unless an external force is applied, correct? So, in this case, your force is 0, meaning no external force is applied on it, correct? So, your acceleration is 0. Now, this actually proves Newton's first law of motion, meaning from second law you can get the first law. If force is 0 in second law, that is nothing but your first law of motion. Okay, first law. So this is one observation what you can do. Okay, second observation. See, last chapter when you were learning about velocity, remember we did resolution of vectors. Suppose you have a velocity, then you can split it into components. Remember? Now same thing we'll do for acceleration also. See, in acceleration, you have the acceleration. We can split the acceleration into three components. One is in the x-axis, one in y-axis, one in z-axis. Okay? So let's call that as ax, ay, and then az. Alright? Now, force F is equal to m into a. Now, let's say the acceleration on the x-axis you are trying to find out and the force on the x-axis. So, Fx will be equal to m into ax, same thing, Fy is m into ay, then Fz is equal to m into az, right? So, the acceleration with respect to that axis, only that acts to calculate the force. See, so take an example. For example, see, last chapter you guys learnt about projectile motion, right? See, if you remember in projectile motion, so the object was going in a parabolic path. Here, the horizontal velocity was constant, right? We took it that way, remember? See here, why it's the horizontal velocity is always constant? Because the projectile motion, only the vertical velocity is acting on the body, right? The vertical velocity. So here, only the acceleration on the y-axis is acting on the object, not the acceleration on the x-axis. So only Fy comes into picture, not Fx. Okay? So the acceleration on the particular axis, only that comes into picture in finding out the force on an object. Okay? Fine. So, next point. See, next point is, let's say you have an object. Okay. Now, Newton's second law says, whatever the mass of the object times the acceleration gives you force, right? Now, let's say the acceleration of the object at this instant is A. Okay. At this instant is A. Now, the force F depends on this particular acceleration, not the acceleration which was the particle was moving, right? It doesn't matter what was the force or what was the acceleration of the object. What determines the force of an object is the acceleration at that instant. Okay? There is no history of the force which acts on the body. So remember this point. Whatever force you're calculating from Newton's second law, it's all about the instant acceleration, not some history. Understood, right? Okay. Now these three are very important points or observations of Newton's second law. Okay. See, few examples you can see, like how force depends on mass and acceleration. Alright. See, first example is, suppose let's say you have a small toy car. Okay, a small toy car, very less mass and very less acceleration. So what will be the force? Very less. Like, see, even if the toy car comes and hits you, nothing happens to you, right? Now, let's start with a little bit bigger example. Let's say you have a stone. See, stone, let's say the mass of the stone is about, let's say 2 kilos. Okay? So 2 kilo stone and you throw it. If you throw the stone of 2 kilo, see, when you're throwing, acceleration will be very high. Now, the force becomes quite high compared to that of toy car. Because mass is 2 kilos, which is much higher than a toy car, and your acceleration is very high, so force becomes very high. Okay? Let's take one more example. Let's say you have a truck, 50-ton truck. It is moving with a speed of 60 km per hour. Imagine the force of the truck. Mass is so high, acceleration is so high, your force is huge. Okay, force is going to be very, very high value. Okay, so this one more example. See, you guys must have read in all the books and all. An asteroid some 200 million years ago came with a very high force, and then it just crashed on Earth, and all the dinosaurs died and all these things. See, imagine an asteroid. Asteroid has a mass of, I don't know, some 200 million tons. 200 million ton coming with a tremendous acceleration. What do you think is the force? Imagine. So, very high mass, extremely high mass, and then extremely high acceleration. Imagine the force of the asteroid. See, this is the point. Remember, if mass and acceleration are very high, then your force also becomes very high. Okay? So, like this, for any object you see in day-to-day life, it has a force because it has mass and acceleration. Okay? Or it has momentum in it. The rate of change of momentum is nothing but force. Okay? So, in the next videos, you will see different laws of motion and different examples.